Hey everybody, welcome to Chapter 5. We are going to look at loops and vectorization today. So this is Chapter 5, and I would encourage you again to read the book before you look at these lectures. Read the book before you look at the MATLAB tutorials. It's a good place to start. It can be useful to do it in the opposite direction, right? Look at the lectures, etc. But I would really highly recommend that you read the book first. And if you don't understand something, hopefully I'll clear those up in the lectures, the tutorials, or clear them up. Okay, let's get started. So we're going to look at loops. And this is the way of doing something over and over again that you need to do. And this is what computers are great at, right? So this is a way of doing something that a human just couldn't do in the same time, right? So one of the main things that we do with computers. Now, there's something called vectorization in MATLAB, and that just means using MATLAB's sort of powerful, way of dealing with vectors and matrices and arrays to do what a loop can do. All right. So this is pretty much just, I think Python might have this ability as well, but it's really built into MATLAB, and this is where MATLAB can become much faster than just if you wrote loops for doing operations. So let's go through the different types of loop. So for instance, there's a while loop, and this is a type of loop that you would use if you're testing something. So if you wanted to add a number, so let's open a new script file. Again, you might have your script file show up as one of the windows, right, in your environment here, right? But mine pops up separate. Okay, so what if I wanted to say while, first I have to initialize things. So I have to say while a is less than 10, add 1 to a. Okay, so what does that do? Well, it asks if a is less than 10, okay, and then it adds 1 to a, right, updates a, and it'll keep doing that until a is 10, right, and it'll stop because it doesn't say a greater than or less than or equal to 10, it says a less than 10. Now, there's a flaw in that code. If I just wanted to run that, and let me just save that in our code, I'll save this as code examples, new folder, and then we'll call this while loop. Okay, so what if I just tried to run while loop? I might have to add this to the path again, we'll see. Yep, I gotta go add it to the path, so let me do that. Okay, so remember what you do. You gotta go and add the folder that I just made. So I'm gonna go over to my folder, and I'm gonna go to my new folder, I'll open that. It's gonna be added to the path. Hello, save, and close, and let's see. Okay, so, so I better clear everything first. Let's do that again. Okay, so there was something in A already, so I should have cleared my workspace before I got on this video. But I just cleared everything, and then I ran my while loop again. Well, there's something wrong, right? Because when it comes in and asks what is A, so I can start going into this area, right, and doing what I'm told to do, it doesn't have A, right? So whenever you use a while loop, you've got to start with something, right, for the test. So you might want to say, okay, I want to start with a equals 0. Okay, I'll start with a equals 0. I saved it, right? So I just did my Command S. I'm on a Mac to save it. And now I can go back in and try again. So up arrow, and there we go. And it's printing out a up to 10, and then it stops, right? So what about if we just put less than or equal to, save that and see. There we go, goes to 11, right? Because what happens is A comes in at 10, right? So if A was 9 here, it becomes 10, and then when it comes to the loop, it's like, is A less than or equal to 10? Yes. And it does it one more time, and A becomes 11. Okay, so while loops, you have to make sure that what you're testing exists and is a value that you want to enter the loop, right? Otherwise, it won't enter the loop, right? Okay, so whiles are useful. They take a little getting used to, honestly. They're a little harder to use than a for loop when you're just getting started because of issues like this, that you really have to think, okay, what's going to happen when the expression here, so this is the expression here is true. What's going to happen when it's false, right? You need to, because when it's false, the while loop's going to stop, and you got to figure out if that's what you want, right? Okay. So that's a while loop, often useful. All right. What about a for loop? Well, a for loop is a little different. It has an index and then an expression. So, for instance, let's make a new file. Let's see, file, new. Okay, here we go. Make a new file, and we'll call this one for loop, and it's always going to go back to this directory and make me annoyed to have to, okay, here we go. So I'm going to put for loop, okay. And now I'm going to write for I equal 1 to 10, a equal a plus 1, end. And you always need an end for these things. Notice here, right? And MATLAB, the MATLAB editor will always automatically shift things. You know, see how it's sort of shifted in here? And that's really, really important because it doesn't need that to run. It'll run fine if everything's sort of lined up with the for in the end, but it makes it super hard to read. So when you have more complicated code, that indenting is something that is will save your life. So make sure you're always doing that. And the MATLAB editor kind of does it naturally. Okay, and let's see what happens when I run my for. Now I'm going to clear all the variables, and I'm going to clear the screen. Okay, and now I'm going to run my for loop. Let me save it. Okay, all right, for loop. Again, right? I don't have a. So I can initialize a here for this for loop in the same way that I did. Equals 0, okay, and now, whoops, it's just going to save it, there we go, and then we have a equals 0, and then it doesn't really go into the loop. Well, it has gone into the loop. Sorry, it has gone into the loop. It's not showing you that, right? And why is it not showing you anything? Remember what I told you about that colon operator? So imagine that you're doing this loop for 1 to 10,000. You really don't want this to print out to the screen. It also makes it slower, okay? So that colon will save you from that. But right now it's kind of like, well, what happened? Well, in fact, let's look what A is now here by just typing A. A is 10. It actually did go into the loop and do what I told it to do, right? It added 1 to A 10 times, okay? So that's good, but I didn't see it to the screen because I have that colon on there. So use the colon when you, when you have a lot of numbers. And then also, I tend to keep the colon off when I'm writing code so that I can see what's happening. And then when I'm done debugging stuff, I put the colons everywhere, so that it's not printing a bunch of stuff to the screen and slowing itself down. And also it's just messy. Okay, but you can see what the for loop did, right? Now, let's step through this because that's kind of fun. So we're going to put a breakpoint right here. Notice that breakpoint. And I'm going to run it again. And I could also run it for just pushing run, okay? But I tend to just do it on the command line. And now we're stopped. And let's see what is I. I is 1 because it's the first time it goes through the loop, right? And now I'm going to expand this because I need to have my stepping things here. Okay. So I'm going to step. What's A right now? A is 0, right? I'm going to take the step, and now A is going to be 1, right? Because it just got 1 added to it. And I'll step again. And now what is I? I is 2. Step again, right? A is 2, right? Okay. Obviously, I don't need to do it this way, right? I could just set A equals I. It's kind of a silly thing to loop over, right? But you might be doing something else in this loop. All right. But this is a way to make things happen over and over again. All right. Okay. we're going to go over a big example in a second when we finish with the lecture, but I just want to point out that there are break and continue statements that can break you out of the loop. I have literally, in the hundreds of thousands of lines of code I've written in MATLAB, I'm pretty sure I've never used break or continue. So it's a little old school. So you'll see things like break and continue in, old, basic code, right? Or old Fortran code. There's kind of never really a reason to use it that I can think of. I mean, maybe you can think of one. But I've literally never used those. But it's kind of nice to know that they exist. And the break kind of terminates the execution of the loop and then goes to the next statement after the end of the loop. So if you had a break here, right, and we could just see what that looks like. So if, this is just for fun really, if a equal 5, let's break. How about that? Break. And let's go to the end of this loop here and say display I just broke. Okay. All right. Yes. So it's giving me a little editor error because I'm right in the middle of debugging and it's like, you really want to save stuff when you're debugging? I'm like, yes, I do. And I'm going to kill the breakpoint and I'm going to save it and I'm going to for loop. And there you go. And actually, let's take the colon off so we can see what's happening. I'll do it again. Take the colon off, save, and there we go. So when A is 5, it breaks out of the loop and does the thing that's right at the end of that for loop, which is display, right? So it's out of the loop. It's not going back. So once you break out, you don't go back, right? You just continue down with other things. Again, like I've literally never used it. So I'm not sure in what situation you might use it. Now the continue statement terminates the current pass through loop and returns control to the top of the loop. So we can do a similar thing there and just say we'll put this right above. I'm gonna grab it, go here, and I'm gonna say if I equals 5, I'm gonna say continue. Okay, now what is this going to do? Well, it's going to go through the loop like normal, right, until I is 5. And then I'm not going to let it do this part, right, because I'm going to continue kind of breaks it out of the loop and goes to the next one. Okay, so let's see what happens here. All right, and it's doing the I just broke because that's at the end. How about if I comment that out just to not make it too confusing? But let's look. So we have A equal 5. Well, that continue did not work well. Anyway, don't worry about continue. I'd have to figure out why that didn't quite work. But it's not a useful thing. Okay. Anyway, let's go on to the next thing. So more on loops. Now, these are sort of tips on how to do best practices in programming and indenting the body of loops. That's what we were just talking about. It's so much better for your readability. And this says don't modify the loop index within the body of a loop. Okay, so that means that I shouldn't change I inside here. Okay, and that's a good thing not to do. So if you need to make some other index, you can use a different thing, right? And just make it based on I, but just don't change I. Now, if you're doing a lot of work within a loop, so in other words, you're filling an array, or if you're going to modify that array in the loop, so that means like if you're going to make it bigger by adding pieces to it, right? So let's say you have an array that's just a list, right, a vector, and you're adding a number to it every time, so making it bigger, that can be really slow in MATLAB. And so I would pre-allocate your array. And let's take a look at that here. We'll just get rid of this stuff. And we'll get rid of that. And we'll say B of I, right? So that's the index, is equal to I. Okay, so we're now filling an array. We start with an array that didn't exist, B. And we're going to say B of 1 is equal to 1. B of 2 is equal to 2. B of 3 is equal to 3, right? That's what this loop is going to do. Save it. And I'm not putting a semicolon on so you can see what's up. So look, it starts out with b is equal to 1, then it makes it bigger, then it makes it bigger, right? By putting these numbers into it until finally it has 10 pieces in it, right? Well, if this was something much more involved and much bigger, right? If you were going to 1,000,000 or something, right? It would slow MATLAB way down to do this, because every single time you're making the array bigger, right? You're making the vector bigger, longer. And so the right thing to do is to initialize the array to the size that you want it to be, which is 10 in this case, right? So we can say b is equal to 1's, 10, 1 row, 10 columns. I think that's the right way to do it. We can check, so let's check. There we go. Or zeros. That's even better. Zeros. Right? You're just allocating it, right? You're just saying, hey, make this array, make it this big. I'm filling it with zeros, and then I'm going to fill it with something else, right? So that means that MATLAB sort of pre-allocates that memory space for this, and you're not increasing it every time, which just slows everything down. Again, really doesn't matter for something this small, but keep it in mind, because once you start building some big piece of code, it can get out of control quickly. And if you haven't thought about this, then you're going to get yourself into a mess. Okay, let's look at our for loop. Same thing happens. Of course, you're not going to notice any speed difference, but look what happened, right? We started with B being, 1, 0, all zeros, 2, 1, 2, and then all the rest zeros, and 1, 2, 3, right? Because I initialized it as having all zeros. Okay, so that's a good idea for good coding practices. Okay, so this whole idea of loops is often unnecessary in MATLAB. So, I mean, it's not always unnecessary. There are pieces of code that I've written that just could not be vectorized, and they were very slow, and I would write them in another language. Basically, I wrote them in Python and called that Python code from within the MATLAB code. And there's also, you can write C code and embed that into MATLAB code, etc. So there are ways to get around this, and if you cannot do this with what's called vectorization, then you might need to resort to something like that. Okay, because right now you can't tell that loops are slow, because we're just doing little tiny things, and most of your work in this class, you're not going to see that slowness, right? But you need to be aware of it, because if you're ever in a job, in an engineering job somewhere, wherever you are in graduate school, and you got to write some big piece of code that's got to do a lot of calculations, and then you're sitting there for 3 days going like, what's wrong with my code? You need to remember that you need to be diligent about saying, well, can I vectorize this? If you can't vectorize this, what can I do? I can write it in another language, right? There's a thing called a JIT compiler here. I've never used that, but they have that, and that's mentioned in this text, in this chapter, which is supposedly supposed to speed things up. But there are just other ways around this slowness. Again, you probably will not notice this until you are using MATLAB in an application that you're building for work, or for graduate school, or maybe for an undergrad class, right? Kind of depends. But again, I've written big code bases for all kinds of things, and I've come up across it many times. Anyway, but vectorization, let me show you just an example of that, and we'll keep our for loop code, we'll just modify it. Okay, so let's say that I wanted to do, I wanted to fill an array, and I'm going to call that B again. I'm going to initialize it like this is initialized. And I want it to be, oops, sorry, I wanted to keep that I. I want it to be I, and I want it to square I. So I want to fill, I want to have a B that has I squared in there, right? Okay, so let's run this code and see what we get. All right, there you go. You have the number 1 squared, the number 2 squared, the number 3 squared, etc. That's what I want in my B. Okay, well, there's a vectorized way to do this. Now, I'm doing it in a loop, right? I have to loop through every time and to fill this. But the vectorized way to do this is much simpler, although you just have to think a little, and once you've done this enough, it'll be natural to you. You will never think of doing the loop. You'll be like, no, why would I even think of that? So we're going to call C, we're going to say C is equal to 1 to 10, right? Sorry, there we go. So that, let's look at what that does. As you probably know, hope you've been messing with MATLAB and doing your exercises, that's just going to give us 1 to 10, right? Okay, well, if I want my B, and let me clear B, clear, you can say clear B, and that'll clear just B. So I want B to be C squared, right? I want to have every element of C squared. So B equals C dot squared, right? And let's kill this. I'm going to comment this out, so this is kind of nice. You can just highlight everything, and then right here it says comment. You can push the comment button. Isn't that great? And then you can uncomment it, right? And you can comment it. Anyways, it's really nice. Okay, so I'm commenting that out. So it's not going to do anything. And let's see what we get when we run our for loop, which doesn't have a for loop in it anymore, notice. Well, what did I get? The exact same thing. And believe me, if this was a much bigger loop, right? If that loop up there that I was using, this vectorization is like just infinitely faster, so much better. So every time you can do something with vectorization instead of a loop, you should do it. All right, let's see what else we got here. Let's see. Here's the vectorization example. I was basically giving you a similar example. Okay, let's look at something called logical arrays, and I really like this. I use this kind of thing a lot, not exactly in this way, but very similar to this way. And so logical arrays are kind of a really cool thing. So let me show you. So let's say I have a vector, and I'm just going to clear everything right now just because I don't want anything interfering with anything. So now all variables are cleared. Notice there's no variables over here, right? Because I just cleared them. Okay, so let's look at a, let's call B now from -1 to 1, but in steps of 0.01. 0.01 to 1, okay? All right, fine. So we've got, 200 values here, and there's a bunch of negative values and a bunch of positive values, right? So what happens if I take the square root of that, right? Now I'm not going to do that in a loop. I totally could, right? I could loop through that array, right? And let's just look at, actually, before I do this, let me go back to my file, which is over here somewhere. Where is it? Here. And show you just how would you do that. Well, you wouldn't initialize. You already have your variable. What did we call it again? I think we called it B. Yeah. So you already have B. So you would have B like this. Maybe you'd put that up here. So I'll put it up here. Just going to show you how would you do this in a loop, and I'm going to uncomment this. Well, I would go to the length, right? So let me show you something else. So there's something called length, which is kind of like size, but for a vector, it just gives you how long it is. So you don't have to parse out size, because watch what happens when I parse out size. So I say size, size, can't type, B, what do I get? I get, well, it's 1 row, 201 columns. But I really want to know just how many columns, because I don't really care there's only 1 row. I want to know how long it is so I can loop over every element, right? So there's something called length. That's kind of just shorthand. Length, if I can spell length of B, just gives me the 201. So it's really sweet. So I'm going to say I want to go from 1 to the length of B. Okay? And then, and by the way, I hope you noticed that there was a little red line. So if I do that, right? It should pick that up and be like, yell at me about it, but sometimes it doesn't. Okay, and then I want to take the square root of everything, right? Of everything in B, and return it, say, in C. And I'm going to initialize C. C equals zeros. And then this is cool. I can say size of B, and that'll give me zeros with the exact same size. 1 row, 201 columns, right? So that's really nice. So that's my initialization of C, because C is going to give me the square root of every value of B of I, right? So it's going to go through every element, start with the first one, which is -1, and take the square root. Obviously, we have a little issue because you're taking the square root of a negative number, okay? But let's see what I get from this, and I'll show you the vectorized code. I'm going to comment that out and just run my for loop. Not for loop, there you go. Notice what I got, and it's a little easier to see. Let's see. I want to just make it into a column vector, so B equals B prime, right? All right, so I want to see it as a column vector. Oh, not B, C. The output, C equals C prime. And I'll kill this output here. Okay. All right. There we go. So there's C, okay? Notice what it starts with, right? It starts with -1 times I, right? The imaginary number I, and it's kind of messy looking, right? It's all these imaginary numbers, fine. And then all the numbers that have that start with the positive values, right? So then they have only real parts. They don't have any I component, but it still shows up as I, because that's kind of annoying, right? Kind of don't really want that. And so I'd rather have when the number is negative, I want to put out just the imaginary part, and when the number is positive, I want to put out just the real part. Why not? Okay, well, let's not do that with loops. So I'm going to comment this out. Let's do it with these logical arrays. So what can I do? Well, let's notice that if I have, so my B is my, let's make B prime, there we go. B is my big long vector of, -1 to 1, right? What if I said LB, for the logical of B, greater than equals B greater than or equal to 0. Okay, so what is that doing? Well, it's defining something called LB, which stands for logical B, whatever, and it's asking where's B greater than or equal to 0. So let's see. Okay, let's make that into a column vector so I can look at it easier. And what does it tell you? Well, it gives back 1 whenever B is greater than or equal to 0. So now if you look back, it's going to be 0 whenever B is less than 0, right? So the cool thing is that watch what happens when I put this in. So put this in as an index for B. So B, and then I put LB, right? So now what it's going to do is it's going to return all the things where LB is 1. So if I scroll back here, it's only giving me the elements of B that are where LB is 1, where B is greater than or equal to 0, right? So that's pretty nice. So I can use that to give me just the real part, right, of the square root when B is greater than 0, right? Or greater than or equal to 0. All right. So how would I do that? So let's just go back to our code, and I've commented everything out here, but I'm going to redo what we just did. So we're going to have B is equal to -1, going in steps of 0.01 to 1. Okay, there we go. And then I'm going to have LB, how about, B, I'm going to call this actually B greater than equal 0. Greater than equal 0. So you can name your variable whatever you like. Okay, and that's going to be a logical array for B greater than equal to 0. Right? So it's going to be filled with 1s and 0s because it's a logical array, and it's going to have 1s wherever B is greater than equal to 0. Okay, and now I can take the square root, where let's say C is equal to the square root of B with BG, right? Taking only the indices, right, where BG is equal to 1, right? BGTEQZ is equal to 1. Okay, so let's see what happens. Let's do this again. This time I'm not even going to run for loop. I'm just going to copy and paste it into here because it's easier. Okay, and notice what happened, right? So what is this? This is C, and C is the square root of B wherever this this logical array says you're good to go because B is greater than or equal to 0. Okay, so what if I just want to do the square root of, so C imaginary is equal to the square root of B. And how do I get the ones that are less than or equal to 0? I can say not BGT TEQZ, right? So that'll give me all the places where it's not greater than or equal to 0. And let's see what happens here. Probably going to get all those complex numbers. Oh, yeah, well, I got to spell the thing right. Here we go. Okay, there's all those complex numbers. Okay, so if I want to get the just the complex part of that, so let's look at our CI again, right? So CI has 0 plus all these imaginary parts. If I want just the imaginary parts, I can say imag. That's another built-in functions of CI, and I get just the imaginary parts, which is what I want, right? So what I want is the square root. When it's a negative number, I want just the imaginary part of the answer. Okay, so that's how you use these arrays, these logical arrays. Okay, let's look at, so the MATLAB profile is something a little bit advanced for this, and I think you can play around with it. It can be useful, but really only for bigger codes, but it's nice to look at, and I would go to your book and see how to use that. Text read is this your very first function for reading stuff from a file. So it can be, this is one of the hardest parts of MATLAB, is reading things from a file. You'll probably see why in this class. We're not going to spend a lot of time on it in this chapter because there's a whole other chapter where we're going to spend some time on that. Okay, let's look at an example from your book. And this is an example that is, let's look at the book real quick so we can look at the book and you can see the example. Okay, well, let me log in. I'll come right back. All right, so what we're going to look at is this example from physics, just the flight of a ball. And just to remind you what the equation for y of t is, right? So remember that in trajectory of projectiles, right, that you have the only force that's acting is gravity, acting down. So nothing is there to affect the x, the x motion of flight. There's no force, right? So basically that's all dependent on the initial velocity. All right, so what we want to do is look at a piece of code that is meant to calculate the trajectories of a projectile and find the ranges for a range of angles from 0 to 90. Okay, so let's just take a look at the code itself. So I'll go to my directory where I've saved all the code. Again, you can download all this code, right? So we're going to go to chapter 5, and we're going to go to ball.m. Okay, so let's take a look at this, right? So what are we doing? We're just going to sort of walk through the code, and then we'll run it. And I encourage you to play with this, go in and change things, right? Run it yourself, make sure you understand every little piece of it. So if we look, right, we have the constant setup, right? So this is conversion between radians and degrees, because in MATLAB everything is radians, although there are versions of the sine and cosine functions that you can use that are in terms of degrees actually. And I believe, if I remember correctly, let's see, let's just look. It's like help sine d. Hello, yeah. So it's the sign of the argument in degrees, right? So sine d, this can be in degrees. Anyway, that just saves you having to convert to radians. If you want your user, say, to enter things in degrees, right, or you want your code to be in terms of degrees, you don't have to convert if you use that function. It's kind of handy. It's, just like a calculator that can go back and forth between those two units. Okay, so, but that's not what they're doing here in this code. So they make a conversion. They set G minus 9.81. Obviously, there's no units here, right? It's just a number. Okay, and the initial velocity is set to 20 meters per second. And they tell you all this, of course, in the nice comment section that they have at the beginning of the code. Okay, really nice. All right. And then what they're using here for an index is I. Now you can use anything, right? So, in the for loop, when I wrote for I equal 1 to 10, you can use anything you like as the index, right? You could call it my index. For my index equal 1 to 91, right? It can be anything. That's a valid variable name. Okay. It tends to be traditional to use I and J, even though and they're using I here because I is kind of reserved for that, square root of minus 1. But notice that I used the letter I by itself. It's kind of traditional, so I don't, MATLAB allows me to use it as an index and doesn't, get mad at me for doing that, right? So you're free to use those things. And they're using I here just to be like, okay, I'm not going to use I, right? But I and J, K, these kind of things tend to be the index that the variables that people use for indices. Again, they're using I because they don't want to use I because I is reserved. But feel free to use I because it's ubiquitous, right? Like, anyway. Okay. So they're looping from I equal 1 to 91. It's kind of silly that they don't just go from 0. So there's no reason that you can't go from 0. Okay. But why not? Let's just see what they're doing. And this is one of the things that you need to learn as a coder. If you're going to write code in your life, and most likely if you're going to be in a science field, you're going to write code, is that you need to be able to read other people's code and figure out what they're doing. Maybe you don't understand why they did it that way, but just figure out what it does. That's what you need to do. All right, so in this case, they're setting the angle to be I minus 1. So obviously the first angle will be 0, right? Okay. And the next angle will be 1 degree, and the next angle will be 2 degrees, etc., up to 90, right? Which is what they said in the book that they wanted to do. And now we're calculating the x and y components of the initial velocity, right? So v0 cosine of theta times that conversion, because theta is in degrees, right? We want it in degrees, and they're converting to radians. All right. And then they're calculating the maximum time, right, for the time of flight. And that's pretty simple to calculate. If you look back here on the book, they do it for you. Here is the equation for where the ball is at all times in y. And if you set that to 0, right, that's going to tell you and then solve for time, right? That's going to tell you where it is when it hits the ground again, all right? But t, as you notice here, right, you're saying, okay, at 0, it's 0, and you start at 0, right? So you're starting at 0 and you're shooting something up, all right. And then you can see t has 2 roots here. T equals 0, but that's when you threw it. And then t equals this, which is the time of flight. Okay, all right. And notice g is negative, so this thing is not going to be a negative time. It's going to be a positive time. And then the range is just the initial x velocity, right, which never changes because there's no forces acting on it, times that maximum time, and that tells you the range. And they're getting that range for every theta, right? They're making an array of ranges. Okay, so let's run this and just step through. I'm going to make a little breakpoint right here. Okay, so here we are. It ran, and now it's waiting. And I'm going to step, and the range is just initialized, which is a good practice. Initialize your arrays with zeros like we saw. And then I'm stepping, and I get theta, get these let's look at the first range. Okay, so the first range is 0, right? For 0 degrees. Doesn't that make sense? You're throwing the ball at 0 degrees, right above the horizontal. Okay. Anyway, so let me show you something about debugger that's kind of cool. So I could step through all of these 91 times. It's kind of annoying, and look at range. Notice I'm starting to get some numbers in there, right? As theta increases. And that's in meters. But I don't really want to do that. Once I see it works once, I could be like, okay, well, I trust that. This is a cool thing. If you put your cursor, see how the cursor is blinking right here? You can say run to cursor, and it'll just do all that stuff and go there, right? So that's really handy. And now we're gonna print. Okay, so here we go. Range versus angle, theta. That's what it just printed out. And now it's gonna go into a loop, and I'm gonna step in, and it's looping through theta again. Kind of not great coding practices. So it's a good exercise for you to take this code and make it a little better, right? Because it's a little old school and funky. Like, for instance, I would make theta into an array that just holds the values, and then I don't have to do this again, right? But, you know, that's what this person decided to do. Okay, so they're looping through theta and making theta again, right? Starting from 0, because look, here's theta 0. And they're printing it out. And they're printing out the range. Well, the angle's 0, the range is 0. Okay, let's step through a couple more times. There we go. So for 1 degree, it's 1.4 meters. For 2 degrees, it's 2.8 meters, okay? All right, and I don't want to keep going, right? I want to just go. I'm going to run to cursor, put my cursor here, and run to cursor, and notice to put out all those things. And for all the different angles, again, for 90 degrees, the range is 0. It's going straight up, right? Okay, so if we go kind of scroll back, I bet you can tell where that maximum range is. Yep, it's right here at 45. I hope you remember that from physics. Okay, anyway. All right, so let's just keep going. Okay, so now what is the thing doing now? It's saying, I want you to get the maximum of this thing, because a human is not going to look at that list like I just did. So let's step and see what happens. Okay, well, it is the max range. Yes, it is 40.7747 meters. And where is that? Well, it's index 46. And if we look over here, right, oh, I gotta go back up. Hello. I hate scrolling. 40.77. Right here, the index is 45. This is the angle, but that's also the index because it was going up, right? Okay, so the tells you where it is, and it's actually not the angle. So yeah, 46 was the index. Okay, so the angle is 45, right? Because you can see this is printing out angle, not index. Okay, all right. So we step and we say max angle, 45 as we know it should be. Okay, and then we're going to print that out. Well, step. Did I step? There we go. Max range is 40.7747. And if I were them, instead of just saying 40.7747, right? And this is, I would say meters at 2 degrees, right? So that's what I would say. So I just changed that. I'm not going to save it because it's going to yell at me and want me to come out of the debugger. But so if you look at this thing, it says start with the carriage return, print max range is, and then this percent 8.4f means a floating point number where you have 4 decimal places. So that's controlling the format. And percent 2d means an integer, right, with 2, using only 2 numbers, okay? So like 45. And then it does another carriage return. Anyway, but I put meters here, so next time we run it, well, you'll see, it'll say meters. All right, after I save it. Let's step and see what the next thing is doing. All right, now we're going to plot the trajectories. So we're going to start from 5, and we're going to go in increments of 10 up to 85, okay? All right, so we're going to, theta is II, okay, so what's theta? 5, okay. And then we're going to get the initial velocity in the x direction, in the y direction, getting the max time again. Again, if you look up here, right, if you made vx0 and vy0 an array and max time array, you wouldn't have to redo those calculations. Okay, that's kind of bad coding. up here, you could have made these all all these calculations, and then you wouldn't have to do them again. Okay, but anyway, fine. So and now we're just going to calculate the XY positions. Now, all of this stuff is being done in loops, and a lot of it does not need to be done in loops. So we'll look at that possibly today. Okay. All right, so let's just keep going. So we're initializing arrays, and now notice that we're making another loop that's inside one loop. So I have a nested loop that hopefully you've read the book and you know what I mean by that. So you've got a loop that's looping over I, and now you have a loop inside that loop that's going to loop over JJ. So what happens is you're going to start looping over I, and then when you get to the JJ loop, you're going to do that as many times as it says to do it. And then when you're done, you come out and you're still in the I loop, and you're going to go back and do it again. So that's a nested loop. So let's see how that works. So we're going to have JJ, and then we're taking the time, right? And we're just looping over, max. We're getting the time in increments of 20, okay? And we're just adding these to X and Y with the equations that we know, right? So X just is V0 times time. So that's the, where is it in X? Where is it in Y? It's V, and it's the Y direction initial velocity plus 1/2 time. Oh, sorry, plus 1/2 G times time squared, right? So this is V0 times time. So that's just Y. That's from the equation that we've seen before. And that's assuming that the Y, the position of start is 0, which that's the setup that we're using. Okay. And then, of course, you would just loop over and over again. So look, we're going through that J loop, over the JJ loop, over and over again, over and over again. Again, all of this can be vectorized, and it's a very good exercise for you to take this code and vectorize it and fix up all the craziness. Okay. Now, I'm not going to keep stepping through that. It's annoying. So I'm going to put my cursor here, and I'm going to run to cursor. Okay. And now I'm going to step, and what happens? It plots that trajectory, right? So that's cool. And then if I equals 5, it's going to put a hold on so that the other plots are going to be right on top of that. Okay. And I is 5 because we just, yeah. All right, let's go through one more. And I'm just going to go into this loop and then step to the cursor again here. I put my cursor back there to do that. And then I'm going to plot again. And look at that. We have another one. Okay. So that's cool. All right, so I'm going to step out of this by running to cursor. And now these little things are just going to put the nice, so look at all our trajectories, right? Kind of nice. Let me move it out of the way. Here we go. Right, so we're going to now put titles on it. And I want to explain this. See these little weird characters? It's like backspace BF, and then trajectory of ball versus initial, and then backspace theta. These are tech commands like LaTeX, and I hope that you should look it up if you don't know what that is. It's a typesetting program that pretty much all scientists use to write papers and things like this, because it allows you to write equations really beautifully and neatly. If any of you have been in my classes, you've seen tech because I use them to make tests. Well, LaTeX. And you can look this stuff up. So if we look over here on my browser, you can see that I've looked up, and I just looked up on Google. I didn't even use the documentation that comes with MATLAB, but it's all online. It's telling me about the title command, because the title command and all the commands that put labels on plots can use tech. So if you look down, that tells you all kinds of, it tells you all the different things that you can use. Way down here, way down. Okay. It tells you, yeah, so here we go. So \BF means bold font. \IT means italic font, so on. And \RM means just normal, go back to normal. And then there's all kinds of other things. And then there's all kinds of things you can use, like if you need a theta, right? Like, where's theta? Here it is. \theta gives you a nice Greek symbol on your plot. Okay, so it's really nice to have available tech to put on plots. So if you need some funky character, some equation on your label, you can do that. Okay, so let's step and see the label, trajectory of ball versus initial angle in bold, and then theta, right? And then here we are with BF and italic. And then for some reason, I'm not sure why they do. Oh, the X, right. So it's really should be with spaces in it. Again, I'm not going to save it. I don't want to get out of the debugger. Okay. So italics S, let's see, what do we get? So we get X in italics, everything in bold, and then meters, right? And in normal font. That's what RM means. Okay, so no more italics. It's kind of like a toggle on and off, kind of clunky, but. And then the Y label, again, same thing. And then we're making the axis the way we want it. So we're setting it to 0 to 45 for X and 0 to 25 for Y. There we go, looks pretty. And then we're going to turn a grid on. This is really a cool command, right? You make a little grid, so it's easier for your users to see, for you to see the values of the trajectory. And then we're going to now we'll plot the maximum trajectory in red. So let's go. Calculating again, which we don't need to do because we should have already calculated those. All right. And then max time, and then again, looping where we don't need to loop. Again, this is a great exercise for you to change this code to be vectorized. Okay, so I'm gonna step over that by running to cursor. And then step for the plot, and there we go. There's our maximum range, right? And then we're turning the hold off for good measure. And that's that. Okay, so again, there's a lot in this code that that is unnecessary looping. And if you were doing this at a much, let's imagine instead of going in units of 1 degree, you were doing in units of 0.0001 degrees or something, right? For some ballistic calculation you needed to make. It's going to be deathly slow. So you really need to vectorize everything. And so one thing is, well, there's a couple things you need to change in this code. This is a challenge for you. I'm going to get rid of my breakpoint. So is that one, when you calculate all this, you don't need to calculate it a second time. Make those into arrays that you can use later. Okay, so that's one thing. And then all of these loops, pretty much all of them, do not need to be here. So it's like, even this one does not need to be here, right? You can define theta as a list, and then you can use the cosine and sine. They operate on arrays, and they'll return back an array. Okay, so this can be so much better. This is written as if it was written in a much older language like Fortran or C, where you really don't have the options of vectorization. So that's an exercise for you to try. You don't have to, unless that's one of the exercises I assigned, and I can't remember if it was. But it's a good thing to try, and so I advise you to try it and send me your results, and I'll tell you if you've done it right. Okay. All right. Well, see you next time.